All right, let's get this started. What we're going to be doing today is we are going to continue our look at attention. We introduced this idea and this topic last time that we met, and we are going to mostly wrap it up today as we're going to take a look at the endogenous and um, exogenesis versions of attention. And then we're going to take a look at the CogLab for change detection and hopefully have a discussion about some of the wider implications of that in the real world. And all of this again is in service of understanding your human mind and what is going on in there. And one of the things that we can do is we can attend to certain stimuli. We can divert our information processing systems to certain things that interest us. Sometimes that's goal driven. Sometimes those things are just grab our attention from outside. So as we began our look at attention, we took a look at serial and parallel processing. So the idea that some information in our mind gets processed one unit at a time, that's serial processing. Other information in our mind gets processed all at once, which is parallel processing. And we saw examples of that with face perception, upright faces, the kind of faces that we encounter by far most of the time. They seem to be processed by a parallel processor in our mind, so that is processed extremely quickly. Whereas upside down faces, we do not encounter that often. They are processed serially, and we saw the patterns that those serial and parallel processors produce in our behavior, specifically response time, when we took a look at visual search. And if you're doing a visual search that can be parallel processed, then the number of distractors or the number of things that are not the target that are vying for your attention, as that number increases, your reaction time stays the same. It's almost like those things do not affect you at all. However, if it's a serial processing visual search, then those reaction times increase. It takes you longer to find the target that you're looking for, the more distractors that there are in the search area. And we're going to see that today when we take a look at change detection and the CogLab that you completed that gave you firsthand experience in that change detection. And we saw just how uncomprehensive our processing of our visual world is. We saw just how little we actually attend to changes in our environment through some demonstrations of change detection, where you might not have seen the moonwalking bear amongst the basketball players, and you might not have seen the 21 changes that occurred in that whodunit tale. And today we're going to continue our look by taking a look at where does attention come from, and we'll answer some of the reasons why we notice some of the changes in the whodunit example and not other changes with the stimulus-driven and goal-driven attention. And then we're going to turn our attention to our first CogLab, which was the change detection CogLab. But first, we do have an exam coming up, and you do have exams and tests just in general in your academic career, I would assume. So one of the things that I always want to do rather early in a cognitive psychology class is just take a look at some of the research that gives you tips in terms of how you can study most effectively, because you're going to have to dedicate time to studying. And wouldn't it be great if you could use some research-backed tips on how to study effectively, so that the hour that you put into your studying gives you the biggest return on investment, rather than that being an ineffective use of your time. Now, this is something that always kind of to me a little bit, that this is chapter 7 in your textbook, which means if you were just following along chapter by chapter by chapter, you would have spent 6 chapters studying and then be told, well, maybe what you're doing is kind of ineffective. So we're going to get right to this in week 3 before the suggested time for the first exam. So let's get to it. What are the effective techniques for studying? What does cognitive psychology actually say are the techniques that you should do in order to make the most use of your time and get that biggest return on investment for your study time? Now, just to kind of give you a spoiler alert, this video here shows one technique that is very popular and highly ineffective. And then another technique that is also somewhat popular and more effective. So let's take a look at which ones are good and which ones you should try to avoid. All right, so effective studying. So the first thing that we're going to point out is that one of the most popular ways of studying is to highlight material in your text or your notes, and then also rereading your text or your notes. So you have assigned readings, you read them once, and then before the exam or midterm, you go back, you read them again. You make notes, you read them again before your test, and you highlight material in the text you're going through, and you're thinking to yourself, well, this is important. This is important, much like what I did on this screen. However, even though those are the two most popular methods that students use to study, research has generally found that these techniques are not very effective. So highlighting is not an effective technique to kind of transfer that information into your mind so that you can get it later on during an exam or during a test. And rereading is also not that effective, and we are going to see why in just a moment. One of the reasons has to do with an idea called elaboration. And elaboration is a process that helps you transfer material that you read into long-term memory. And what elaboration is, it's when you think about what you're reading, which really is just reading comprehension. Hopefully, as you're reading your textbook, you are thinking about what you're reading. I know occasionally myself, I will sometimes get to the end of a paragraph or two and then stop myself and think, well, what is it that I just read? Like, I don't even know what it was. Sometimes your mind wanders, and that's fine, but get into the habit of thinking about what you're reading. However, most effective if you can go beyond that by giving it meaning, by relating it to other things that you know. So that's the elaboration part of this. So it's very important as you're reading these topics to think about, well, what does this have to do with other things that I know? How can I connect it to other pieces of information, other concepts that I know, maybe from other classes, maybe from real world experience? And you'll notice that oftentimes in this course, we try to connect things that we are seeing in the lab to things that are occurring in the real world, right? So we'll try to connect attention to facial processing. We'll try to connect attention to some sort of like visual search to show you how these things can impact the real world. And today we're going to take a look at change blindness, and we're going to try to connect its effects and its phenomenon to things like racism, sexism, and other social ills. So that's the kind of thing that you really want to do to help make these concepts strong in your mind, elaborate on them, connect them to other things that you know, connect them to other pieces of information that you already have stored in your mind, and that will kind of solidify their grip and their staying power in your mind. All right. Another technique that you can use is to generate and test. So research on retrieval, practice, and testing effect indicate that repeatedly testing yourself on material you are studying pays dividends in improved memory. So things like doing a pre-test and a post-test. There is a reason why we have pre-tests and post-tests in this course, is because repeatedly testing yourself on that material helps you retain the information better. It's better to spend your hour not rereading your textbook, but rather actively testing yourself on the concepts that are in those readings. Now, one thing that I will mention is that it's great if you can generate the questions yourself. That is something that has been shown to be highly effective. You can also use questions that might be provided in the book that aren't on any of the pre-tests. Definitely use the pre-test and the post-test. But one thing that I'll also mention is that now that we are in the age of generative AI, being able to test yourself with, I will say, pretty accurate and pretty correct information is literally just a couple of prompts away. So you could go to ChatGPT and say, hey, we just did a chapter in cognitive psychology on attention. Generate 15 multiple choice questions on the 5 most important concepts and, test me on that. So it's very easy to do this in a very quick and efficient manner. And as we mentioned before, research has shown that this is a better use of your time. So this isn't like in addition to rereading the textbook. This is instead of rereading the textbook, right? So read it the one time, and then when you go back to study these concepts, maybe try this generate and test method rather than the ineffective ones of rereading your notes, rereading your textbook. Organize. This one, I'll be honest with you, I think this one's kind of automatic, and it kind of comes out from just the way that we structure this course in general. So we kind of group all the attention topics together. We're going to turn to perception next. We're going to kind of group all the perception stuff together. But the more that you can organize your material and create that framework where you can tie and relate certain information to other information, the more meaningful that will be, and the more strengthening you're going to do to that encoding, to that memory that you're making. So this goes back again to elaboration. Basically, creating that framework is elaborating on the material and trying to make those connections to other things in your, in the concepts that you're learning. Always ask yourself, how is this like other things? Like change detection, what does it have to do with serial processing? Change detection, what does it have to do with parallel processing? If you can try to make those links, it'll strengthen your hold on both change detection and parallel and serial processing. All right, this one, take breaks. This is probably the easiest one to do because it simply says when you're studying, it's a good strategy to very often stop studying. So stopping studying is like one of the easier things you can do. But basically it says that your memory is better when your studying is broken into a number of short sessions with breaks in between than when it's concentrated in one big long session. So cramming your material, sitting down and saying, you know what, I'm going to carve out 8 hours this Saturday, and I'm just going to binge read everything that I need for this upcoming exam. That is a bad use of your 8 hours. Right? That is a not effective use of your 8 hours. Way better would be to break that up into 8 1-hour sessions with 15-minute, 30-minute breaks in between, 8 1-hour sessions across different days. Actually, one of the most effective breaks that you can have is just going to sleep. So if you can separate, I never advise students to study in your bedroom, because bedroom should be for sleep, and you don't want those cues to tell you that, oh, it's time for your brain to be active. But if you can set it up where you can do your studying and then almost immediately just go to sleep, then that is actually one of the most effective ways because you can use for studying, because a lot of your memory is consolidated during sleep. And you will notice, kind of just introspect from your own experience, if you study and then do not have a good day's rest, or if you have just experiences and then do not get a good day's rest, it's harder to bring those experiences back to mind than if you had experiences or studied and then had a good night's sleep. It's just the way your brain works. A lot of consolidation, which is taking that information that is in short-term store and putting it into your long-term memory. That happens during sleep. So if possible, schedule your study sessions right before you go to sleep. Do a study session, and then for that 20-minute break, take a nap. It's time to normalize naps in this society. They're actually highly effective. And one of the pieces of research that I remember about naps was that if you take a nap in the afternoon, that is in that kind of 20 to 45-minute window. So we're not talking about like a 3-hour, long session. But if you take a nap that's between 20 to 45 minutes in the middle of the afternoon, this was done on workers, are actually like 20% more effective and do more work during the day than people who skip the naps. So people that kind of plow through and say to themselves, you know what, I don't need naps, what is this, kindergarten? They're actually getting less work done and being less productive than people that take those naps. So for no other reason than that, let's normalize naps, but also as part of a study strategy, not a bad idea. Study for about an hour and then lie down, set your timer, 20 minutes, 30 minutes if you have some trouble falling asleep, whatever it is. And then when it pops back up, you can go back to studying. Highly effective way to get that information transferred into your long-term memory. All right, the next one, and this is a big one. This is part of the reasons why testing yourself is highly effective as well, is that it helps you avoid illusions of learning. And one of the things that happens when you do the ineffective strategy of rereading the material, what happens is that you get greater fluency, right? You get greater command of the material. Well, not command of the material. You get greater ability to move through the material, right? You get a greater ability to surface process the material. It's almost as if I was trying to read the top sentence here, one of the conclusions of both basic memory research and research on specific study techniques. If I read that over and over again, one of the conclusions of both basic memory research and research on specific study techniques, one of the conclusions of both basic memory research and research on specific study techniques, one of the conclusions of both basic research, memory research and research on specific study techniques, I have increased my fluency. I basically did no learning in that at all. But as I'm reading through it now, it seems easier to me, right? The first time through, oh man, was that a difficult paragraph to read. But the second time through, it kind of seems a little bit easier. And the third time through, it seems even easier than that. That can be an illusion of learning because that is simply greater fluency. And also you have that idea, or you have the phenomenon of the familiarity effect, where you might have seen terms before and they were highly confusing, but now you see them again, and you see them again, and you see them again. Maybe you still don't know what they mean, but now they're actually a little bit more familiar. So this is kind of seen in that classic response when you ask somebody if they know something. It's like, do you know cognitive dissonance? Do you know what cognitive dissonance is? And they took a cognitive psychology course or an intro psychology course, and they say, well, I know of cognitive dissonance, right? That's because of that fluency and familiarity effect. So you know that you've seen it, you know that you're familiar with it, but it just hasn't been transferred into your long-term memory. So you want to avoid those illusions of learning. So this is one of the reasons why you don't want to highlight as well, because highlighting gives you that illusion of learning. Again, you want some more objective tests, like generating your own test questions, doing the pre-test and the post-test. But just to kind of show you some of the research that's been done, when Sarah Peterson tested students that highlighted study material and compared comprehension for a group of students who highlighted and a group who didn't, she found no difference between the performance of the two groups when they were tested on the material. So she took two groups of students, one group highlighted the material, the other group just read the material. And when they were tested, there was no difference in their performance, showing that highlighting is extremely ineffective as a standalone kind of study technique. So highlighting seems to be extremely ineffective. Does that mean that highlighting is useless? No, it does not. What it does mean, though, is that highlighting is your first step. So for any of you that are highlighters, I know I like to highlight, clearly I'm highlighting this, but for any of you that are highlighters, it's not that this is a waste of time. It's not that it's ineffective. It's just that it is part of the first step, right? It's that first step in a sequence of studying. And one of the things that is part of is this idea of being an active note taker. So what does an active note taker mean? An active note taker means that you are actively participating in your note taking by making decisions about what to take notes on, by making decisions about how to phrase those notes that you're taking, by making elaboration during your note taking, putting things in the margins about, well, this is kind of like parallel processing, or this one actually kind of reminded me of endogenous attention. That's what being an active note taker means. So if you're highlighting, That's fine as a first step in your active note-taking procedure. What you want to do is you want to then go back to those highlights and start engaging in the process of elaboration. Start writing down what it was that you highlighted. What is the meaning of that? Can you generate different ideas? Can you connect it to a real world phenomenon? Can you use it to explain something that happened to you personally? All these kind of things will help you understand that material. Now, some of you are going to be seen very publicly at this next moment. And I just want to let you know that I love technology. I love taking notes on computers. My handwriting skills, I get tired after like 2 sentences right now because it's been so long since I've practiced super long handwriting. But I will say that computer note taking can result, and this is the key, can result in shallower processing of material and therefore poor performance on exams. And what we mean by shallow processing is processing material at a surface level, basically at a basic comprehension level rather than getting deeper. So elaboration is an example of deeper processing. Shallower processing is just kind of reading, well, what's like computer? I understand computer, I understand note, I understand taking, I understand shallower, I understand processing. But elaboration, deeper processing would be taking a look at that and saying computer note taking can result in shallower processing. Oh, wait, can result. That means that it doesn't necessarily have to result. So I wonder what the ways that it doesn't result in shallower processing would be, and what are the ways that it does result in shallower processing. There has to be some sort of divide there. That's what we mean by that deeper elaborative processing. So why does computer note taking possibly lead to shallower processing of the material? Well, the reason is because note taking with computers is way easier than note taking by hand. And what I mean by that is that it's way more effective, it's way more efficient. You can write down way more of the material than I'm saying. And while that is a wonderful feature, it also is a enticing trap for students because what they found in research is that when they looked at laptop notes versus handwritten notes, the laptop notes contained more word for word transcriptions of the lecture. And because of that, they performed worse when tested on the lecture material. So because it's so easy sometimes to just type what the professor is saying, because it's much more effective to take notes when you're using your laptop, you fall into that trap of just doing word for word transcription of the lecture. And word for word transcription is not deep processing because you don't have to understand a single concept that I am saying in order for you to write down everything that I'm talking about. If I was giving a lecture on advanced quantum mechanics here, and none of you had the background for anything to understand in advanced quantum mechanics, and I was talking about entanglement principles and string theory and quarks and annihilation, dark matter, you don't need to know what any of those things are to word for word write down string theory and quarks and entanglement and annihilate. You don't even need to know what those mean. You can write it down word for word, which means that writing down word for word doesn't activate those deep processing mechanisms. On the other hand, if when I was talking about laptop notes contain more word for word transcription of the lectures, and you wrote down laptop notes contain more word for word transcription of the lectures, yes, they do. I've just noticed I transcribe every single word there. Well, that's deeper processing. And that will help you retain that information a lot better. So it's not that laptops are inherently bad, but it's that they allow you to fall into that trap of just writing down a transcript of what I'm saying rather than when you're note taking and I say something like, well, laptop notes contained more word for word transcription of the lecture. And you're sitting there going, well, I can't write all of that at that speed. I can't make those notes. So I gotta summarize this in a way that makes sense for me. Laptop equals more word, therefore not good processing. Well, that boiling it down to those basic ideas forced you into elaboration, which then enhances your learning of that material. All right, and what do we have here? So shallow processing associated with simply transcribing what the professor is saying. Creating handwritten notes are more likely to involve synthesizing and summarizing the lecture, as I just said, which results in deeper encoding and better learning. So basically, what this means is that if you are using your laptop, and I fully encourage anybody here who is wants to use their laptop, their tablets, absolutely do that 100%. But just be aware that you don't want to transcribe those what I'm saying word for word. As important and as measured as every word that I say is, it's not effective studying techniques. All right, so what do they recommend? Well, I didn't even highlight number one, but I'll read that one. Leave your laptop at home to avoid the distraction of the internet and social media. So I'm giving everybody here the benefit of the doubt. I don't think anybody on their laptop is, cruising Facebook or X or whatever right now. But it also says write your notes instead of typing them because handwriting encourages more reflective, deeper processing. You can do that, but also you can actively make the choice and actively use a strategy of doing the more reflective, deeper processing. So handwriting forces you into that strategy. Laptop writing, laptop note taking doesn't, which just means that if you are a laptop note taker, you're going to have to actively on your own make sure that you're not transcribing word for word and you're actually elaborating and summarizing and using the proper techniques to increase that encoding. So what you can do is, every once in a while, after you take some notes, just scan them really quickly. When there's a little break in the action, when maybe somebody has a question, just reread the last 3 sentences of what you wrote down. And if they're word for word transcriptions, that's your check to basically say, okay, I got to be more intentional with not writing down things word for word, so I can use this time to elaborate and get that encoding going into my mind. All right, so those were the tips from the textbook, research-based strategies on how to study. Any questions on that? All good? All right. Okay, so we are now going to return to our look at attention, and we're going to take a look at the last kind of new concept that I wanted to cover, which is where does attention come from? So we saw that we can attend to certain streams of information, and then we can choose not to attend to other streams of information. So the serial processing versus parallel processing example that was shown, and also if you remember in the whodunit example, I asked everybody here to pay attention to the inspector's coat, and everybody noticed the inspector's coat change. However, other things were not asked to be attended to, and only some of those changes were noticed. So where does our attention come from? How do we select information that is going to be processed? Well, one of the best examples of the two ways that, or the two sources of attention comes from a movie called The Matrix. So I love The Matrix. It's one of my favorite movies of all time. I do realize that it came out in 1999, so it might be a little bit before everybody's experience here. And anytime I introduce it, I can't help but remember that it's from the 1900s, which reminds me of this email that a professor tweeted out. And it goes, "Good afternoon, Professor Penniman. Hope you had a great break. I wonder if it would be acceptable to use sources from the late 1900s for our final paper. I found an interesting paper from 1994. Is there a cutoff date of publication? See you tomorrow." My favorite response to this was, "I feel like a dinosaur," because there are things that, are from just about 25 years ago, but they are from the 1900s. So we're about to see a clip from a film in the 1900s. And again, The Matrix is one of my favorite films of all time. I think I could probably structure an entire cognitive psychology course just on the concepts that were introduced or shown in The Matrix. But what we're going to do right now is we're going to take a look at a clip where Neo, played by Keanu Reeves, and you'll be able to recognize him because he looks exactly the same 25 years ago as he does today. Neo is being trained by Morpheus, played by Lawrence Fishburne, who does not have the immortality gene that Keanu has. So he's being trained on the Matrix, the simulation that they are currently in, and he basically is trying to give him the rundown of how this simulation works.
The Matrix is a system, Neo. That system is our enemy. But when you're inside, you look around, what do you see? Businessmen, teachers, lawyers, carpenters, the very minds of the people we are trying to save. But until we do, these people are still a part of that system, and that makes them our enemy. You have to understand, most of these people are not ready to be unplugged. And many of them are so inert, so hopelessly dependent on the system, that they will fight to protect it. Were you listening to me, Neo? Or were you looking at the woman in the red dress?
I was.
Look again. Freeze it.
All right. So there we have Neo being trained in the Matrix by Morpheus. If you haven't seen the Matrix yet, you can watch it. You can actually, it works as an amazing prequel to the John Wick series as well, which some people have theorized is just part of this simulation that they're in. But anyways, that one little clip there was a very succinct example of two of the sources where our attention comes from, two of the main sources that our attention comes from. So let's take a look at those two, and we'll illustrate where it came from. The first one is stimulus-driven attention. So this is attention that comes from the stimulus itself. There's something about the stimulus that grabs your attention. There's something about the information that's coming in from the external world that grabs your attention. And in this clip, that stimulus-driven attention was the woman in the red dress. So the woman in the red dress, nobody told Neo to pay attention to her. She wasn't part of an assignment that he was trying to accomplish. She wasn't part of any kind of goal that was given to Neo. She was just a woman in a red dress. But this woman in the red dress, in the sea of these black and white businessmen, just stood out, basically grabbed his attention, and led him to do some extra processing on this particular individual. So this stimulus-driven attention, this is known as exogenous control, and that comes from exo meaning outside and genus meaning generated. So this is stimuli that grab our attention, and it comes from the outside. So the attention is generated, genus, from the outside, exogenous control. So this is stimuli that itself, just because of certain features of that stimuli, such as salience, such as standing out from the other types of stimuli that are in the environment, it just grabs our attention, and this is attention driven by the stimulus. So this is the one side from where our attention comes from. It actually comes from features in the stimulus that just grabs your attention and pulls it towards processing of that stimulus. And then we have the flip side, which is goal-directed attention. And this is known as endogenous control, endo meaning coming from inside, and genus meaning generated. So in this case, the example of endogenous control is when Morpheus tells Neo or asks him, were you paying attention to me, or were you looking at the woman in the red dress? And he's stammering. He's like, I would. And then Morpheus tells him, look again. Basically, Morpheus is telling him, I'm giving you a new goal. I want you to process that woman in the red dress a little bit more. I want you to process more of her information. So this was goal-directed attention. And we basically then move our attention. It's not grabbed by an outside stimulus. We move our attention, and this attention is driven by our goals. In this sense, the goal that Morpheus gave Neo to to pay attention or take another look at the woman in the red dress. So keep in mind endogenous versus exogenous sources of attention, because we are going to talk a bit about that or tie that in to our discussion of what's coming up next, which is the Cog Lab. So before we go to the Cog Lab, any questions about endogenous versus exogenous control of attention? All right, let's take a look at that Cog Lab. Okay, so in this first Cog Lab number one, this is the change detection Cog Lab. So two pictures were presented in alteration, and your task was to just detect if a change occurred in the picture. So 50% of the pictures were identical. So two pictures that are exactly the same would be presented in alteration, and you were to indicate that there was no change. 50% of the pictures had something that was different, and in that case, you would indicate that there was a change. And then on top of that, whether or not they were identical or whether or not they had a change, there were two conditions. One was no flicker, in which the pictures immediately appeared one after another with no intervening stimulus in between. And then the other one is the flicker condition, where gray lines appeared in between the pictures. So let's take a look at the flicker condition first, just to kind of remind you of what you saw. So in the flicker condition, you would see a picture like this. And then those gray bars would be presented between the pictures, and then it would go to the new one. So this is basically a recreation of the flicker condition, and you are to decide whether or not there is a change in these two pictures or whether or not they are the same. So hands up if you think there's a change. Hands up if you think there's no change. You are correct. This one is actually no change. So spoiler alert, this one has a change. So hands up when you see it. But again, in the flicker condition, you have that gray box in between the two pictures, and then you have the new picture. So hands up once you see. I think we got most of them. So what is it that's changing? The light. So that light there that is on that lamppost, that is disappearing. So a rather large portion of the picture is disappearing. And once you know where it is, it's almost impossible to not see the change. However, until you notice it, you do not realize that that piece of the environment is actually being modified. So that was the flicker condition. We also had the no flicker condition. And in this case, there was no intervening gray lines between the pictures. So here we have an example of the no flicker condition, and you let me know if this one has a change or no change. All right, so this one is immediate. This one automatically, you notice that the girl is disappearing from the environment. And then here we have flicker with, let's say, no change. And it is readily apparent that there is absolutely nothing changing between these two pictures. They are identical. All right, so those were the two conditions. And then you were asked to respond as quickly as you could, whether there was a change or no change. So this was something where it was a reaction time that we were looking at. How quickly can you detect whether there was a change or whether there wasn't a change? And also, how accurate were you that there was a change versus no change? All right, so here we have a graph of the percent correct. So this is accuracy. So when there was no change, did you accurately, correctly identify, oh yeah, that's a no change? When there was a change, did you correctly identify that there was a change? So on the y-axis there, we got the proportion correct. It goes all the way from 0 to 100. So got everything wrong with 0. 1 is got things absolutely perfect. 50%, that 0.5, that's guessing. So if you did this with blindfolds on, and you were just randomly pressing the change, no change button, your performance would be at 50%. So keep that in mind when we take a look at how well people are doing in this example here. So on the bottom there, we have the condition that the two pictures were, the condition that you were in terms of whether it was the flicker condition with the intervening gray lines or the no flicker condition. And let's take a look at that flicker condition first. As you can see, the accuracy that you had was at about 67%. Okay, so not that much higher than 50%, definitely higher. I mean, people aren't just guessing in the flicker condition, but it is nowhere near as accurate as you were in the no flicker condition. So these are, before we go on, these are actual downloaded results from students that complete these Cog Labs. So these are actual real results downloaded from the database that we have with the MindTap. So as you can see, you are more accurate in the no flicker condition than you are in the flicker condition. Now, one thing that oftentimes happens in cognitive psychology is a phenomenon known as the speed accuracy trade-off. So oftentimes when you're performing a task, you can do it more accurately, but you're going to have to slow down. Or you can do it faster, but it's going to be less accurate. So we were just talking about transcribing notes. Let's say that you actually had to copy out a passage from, your textbook word for word, and you couldn't use the copy and paste. You just had to copy it out word for word. If I told you that it absolutely has to be 100% accurate, you cannot make mistakes on your transcription of this, part of the textbook. You could let me know, okay, yeah, I can absolutely give you 100% accuracy, but it's going to take a while, right? It might take me like half an hour to make sure that I do this correctly. On the other hand, if I came to you and I said, look, we need that page transcribed and I need it in the next 2 minutes, you can say, all right, yeah, I can do that, but it's not going to be anywhere near accurate. Right? You're going to have mistakes all over the place. So oftentimes in psychology, you have that speed accuracy trade-off, where if you increase the accuracy, you decrease the speed. But if you increase the speed, you decrease the accuracy. So because of that, oftentimes you'll see both accuracy measured and you'll also see speed measured. So if we had a speed accuracy trade-off, then we would expect that the no flicker condition is more accurate. But maybe if we have an accuracy speed trade-off, maybe it's going to be slower. Right, so let's take a look if that's the actual case. So here, once again, we have condition on the x-axis, flicker versus no flicker. We got reaction time, this time in milliseconds. So it goes all the way from 0 at the bottom to 14,000 milliseconds or 14 seconds. And what we find is that in the flicker condition, on average, took 12 seconds before you noticed the if you notice the change. In the no flicker condition, it actually only took 8 seconds. So not only are we more accurate in the no flicker condition, we are also faster in the no flicker condition, which basically is a way of saying we are way, way better in the no flicker condition. In the part where the images are just alternating without anything in between, we are much, much better, faster and accurate at noticing those changes that occur in the environment. All right. So, question now. So let's take a little bit of time. Let's see if we can unpack, elaborate on these results from Cog Lab. So why are we so bad at detecting change? AKA, what does this indicate for how our minds process the world? So any ideas about why is it that we don't have these super change detectors built into our minds? Yep. I'm sorry, can you say that again? It does have it does have something to do with the fact that there's serial processing going on here. One, which, if we were to take a look at these two conditions, the flicker versus no flicker, and one of them is serial processing and the other one is parallel processing, which one would you say is serial processing? The flicker condition, exactly. So when we take a look at the results that we got, we'll stay here with the reaction time one because that one is more indicative. Remember that when we were doing the visual search and you were looking for the B's in a series of P's, or you were looking for the X in a series of O's, you were looking for the O in a series of X's, you were much, much faster when you were looking for the O in a series of X's than when you were looking for the B in a series of P's. So that would indicate here that in the flicker condition, you're doing serial processing, but in the no flicker condition, you're doing parallel processing. So what does serial processing look like in a flicker condition? If you had to solve this, but it was in a flicker condition, what do you think is the strategy that you're using in order to solve this? Or just from your personal experience doing the cog lab, how did you find that you were doing ones that were in that flicker condition? And we were trying to solve this one today. What strategies did people use to figure out if something was changing between the two pictures?
Sexually, the image is going forth, so I tried to like lock my eyes in one space, and then when I flicker, is try to keep that image, see if things change.
So that is the typical strategy that is used to solve this challenge here. So what you do is you basically restrict your processing to a particular area of the image, depending upon how much information you can process, or maybe how much information is in that particular section of the image. Oftentimes, people will go object by object, and you basically serially process the entire image until you hit the change that you're looking for. So in this case, you might say to yourself, well, is it the tourist in the blue shirt? Let me take a look. No, not the blue shirt. Is it the tourist in the orange jacket with the brown boots? No, it is not. Is it the wheelchair sign? No, it's not. Is it the second palm tree from the left? No, it's not. Is it the pirate ship? Maybe it's something as big as the pirate ship. No, it's not. And you basically process piece by piece by piece, serial processing, before you get to the, well, is it that lamppost? Oh, wait, it's something about the lamppost. It's the light on the lamppost. Yes, I found it. Yes, indicate that there's a change. Versus the parallel processing that's occurring here, where you don't have to go piece by piece when there's this change. And there's just something about the fact that that girl vaporizes into thin air that draws your attention to it, and basically allows you to notice that change very, very quickly. So just that kind of mention there, what kind of attention control is being done here? Is this exogenous control that comes from the stimulus? Or is the flicker condition an example of endogenous control where it's goal driven? Yes, absolutely. This is exogenous control. So let's imagine that you didn't know what was going on here. Let's imagine that you're not even taking cognitive psychology and you were late to class and you got flustered and you walked into the wrong room and you just sat down and I was doing this. Even if you did not know anything about the requirements of this experiment, you take a look at this picture and you say, oh, hey, that girl's disappeared over and over and over again. Because there is just something about this stimulus change that grabs your attention. There's just something about that girl disappearing that pulls your attention to there, regardless of what you're trying to do, you will notice this. It'll make you process that information, and that is that exogenous control. It's driven by the stimulus. On the other hand, something like a lamppost, you needed endogenous control. You needed control that was coming from within. So you had to be given that goal where you needed to be told, find the change. And then there's nothing in here because of the flicker that is grabbing your attention. So you needed to go piece by piece by piece. You needed to direct your attention from within to places in the picture and then process those based on the goal that you had. So in the flicker condition, it is exogenous control coming from outside. And it is parallel processing, but in the in the flicker condition, it's serial processing and endogenous control, piece by piece processing, and the goal comes from within. It comes from the fact that you were told, detect a change. But with the no flicker condition, that is exogenous control, something about that stimulus change just grabs you, and it you don't need to be given that goal, and it's parallel processing because it's almost immediate that you notice that. All right, what implications does this have for AI? Anybody have any ideas? All right, I'm gonna come clean. I can't remember why I wrote this prompt in terms of what implications this is have for AI. So I'm gonna assign that as a kind of take-home challenge. If anybody can come up with an idea for why I might have written that, I would highly appreciate it. So we already talked. Yep.
I feel like, I'm not sure if it's accurate, but I feel like AI always kind of scans an image all at once, doesn't kind of section it down. In my mind, at least that's how it works.
Mhm.
So it only has one kind of like detection.
I mean, that just jogged my mind in terms of why I put this in there. So what you're describing is a way that AI used to work, and that's one of the reasons why it was so difficult for so long to make computers and robots that could function well in our environments, because they were trying to represent the massive amount of information that's in the external world. They were trying to represent it all in the mind of the AI, and then use that representation to let the AI move throughout the world and interact with the world. One of the things that change detection taught us is that that is not how we do things. So we don't represent the entire world in our minds. Because if we did, then in the flicker or no flicker condition, we would notice those changes. We would have had the entire picture of that seaside, sidewalk represented. And when we went to the one where the light is gone, we would have been able to access our complete representation of that picture and say, oh, hey, I can compare these two in my mind. The light is gone. So what that means basically is that we don't represent the entire environment in our minds. We represent portions of it. We represent kind of the gist of what is out there, but we just don't have the cognitive capacity to represent everything that is out there in our minds to detect these changes. So when AI tried to represent everything that was outside in the world, they failed, and they failed miserably. As soon as they basically said, well, let's take a look at what humans are actually doing. They're not representing the outside world. They're not doing, a deep analysis of everything, every stimulus that is out there. Once they started applying that approach, it made AI much, much better and much, much more able to navigate in the real world. So if you take a look at self-driving cars from just maybe 20 years ago, I don't know if this example is still in your textbook. I think it's in the perception chapter, where they talk about a challenge. It was a contest that was given to these universities that worked in robotics, and they were asked to make a self-driving truck that could navigate across a desert trail. And that was it. Self-driving truck, navigate a desert trail, and you don't have to worry about stoplights. You're not going to run into people. Basically, you just need to be able to make it through the desert trail. It was 10 miles long, and the winner went half a mile. That was the best that they could possibly do, and that was maybe like 15 years ago. That's trying to represent the entire environment and move through the entire environment using an internal representation of it. We don't do that. Clearly shown by change detection, because we just don't notice these changes because we're not representing all of that information in our own minds. So, bottom line for this, one of the things that we can always do when we're trying to design intelligent technology for our use is take a look at nature and see what solutions they came up with over the billions of years of evolution and basically engineering, and use that as a starting point for how to do psychology in this case, and also how to do technology. And that will come up again when we take a look at perception, because perception, especially in the early going, went down the wrong pathway, and it took a long time, basically until about 1950, to right the course and get it back on track. But that is coming up next. All right, so we already talked about the no flicker condition, what type of attention is driving the effect, endogenous or exogenous. We discussed that. So what we're going to take a look now is this in the real world. So we took a look at you in the Cog Lab. You had change detection, but it was in static pictures. And in the videos that we took a look at for the moonwalking bear and for the whodunit case, that again was videos. They were from a particular viewpoint. You didn't get to see things that were happening outside of the screen and outside of the viewing angle of the video. So it is a little bit of a contrived situation. So we're going to end today with a look at a couple of examples where this occurs in the real world. And then we'll also take a look at some implications for this in the real world. But without further ado, let's take a look at one example of change detection and just how massively you can change and not have that change do that good.
Most of us think we're pretty observant, but with a bit of mind control, I wanted to see if I could make these people take even the most obvious things for granted. Excuse me. Do you know how to get to Trinity Church from here?
Yeah. You see that church down there?
Yep, straight through there.
And then you keep going down.
Sorry.
Which way? You see where that church is down there?
Yeah.
You stay on that, which is, I believe, Broadway. And then you walk down 2 or 3 blocks, and Trinity Church is on the right-hand side. We're walking in that direction.
Excuse me, you don't know where Trinity Church is, do you?
Might be Wall Street and Broadway.
Okay. Well, we're down here somewhere, aren't we?
Yeah, you see Trinity Church.
Oops, sorry.
Sorry. Yeah. Inside the Trinity Church, right there. Yeah. If you keep going that way, you'll hit Broadway, then you go down a couple of blocks.
Okay.
And,
Thanks very much. That seemed almost too easy, so later on I see how far I can take it. Excuse me, do you know where Trinity Church is?
It's in that direction.
Okay.
Yeah.
Last time I switched with someone who looked a little bit like me, but where's the fun in that?
oh, excuse me.
You know who best direct you? The other side. You see where that lady's standing?
Sure.
That's the pool. No, the lady in the gray.
The other side.
Yeah, the other side of the
But
pool.
you say you don't know where it is?
Exactly what street? No, but it's in that direction.
Okay.
Yeah. Okay.
Excuse me. Do you know where Trinity Church is from here?
Yeah, fine. Come on, I'll take you, or you want to walk now?
I'm gonna catch some other people.
Sorry, guys.
So
Okay,
you're
listen,
saying-
once you go on Broadway,
Yes.
remember the numbers are going... I could have sworn it was another guy. Once you hit the Broadway, you're going down.
Yes.
Walk up straight
that
that
way.
way and just walk straight down. You're
Brilliant.
gonna see it. It's right. It's really brown.
That's brilliant. Thanks for your help.
All right, but don't worry about it. Don't worry about it.
So we're gonna pause it, just real quick there, so, oh, I lose the thing. So, you might have noticed, only one person sort of noticed what was going on. It was that last individual, was the only guy, the only person who did a double take and sort of said, what? I thought I was talking to somebody else, right? So they almost got it. But any ideas, any speculation on why they may have noticed, but nobody else did? All right, think about, we're gonna see a little bit more of this, but think about what were either the way, any differences between the way that person interacted with the person asking for directions, or any characteristic of that person that was giving the directions. Was there anything kind of unique about them? Keep that in mind. Oh, do you have an idea? That is one of the possible reasons why they were the ones that noticed. Exactly. So they were the only ones that spent a lot of time processing the actual individual that was in front of them. Everybody else seemed to be very goal directed, had to get somebody somewhere else. I mean, they're in a busy, urban area. That's not too surprising. But everybody else had, and this is the kind of, again, elaboration that is good for studying, is good to help you encode these things. But everybody else had endogenous control of their attention on other things, right? Everybody else was sort of like, well, I got to get to work. I'm kind of busy for my meeting, or late for my meeting. So I'm not really going to pay too much attention to you. I'm not going to be rude and not help me get directions, but I'm not going to spend a lot of time processing, because I have this goal directed attention driver, which is this endogenous control. I'm trying to attain this goal of getting to a particular place. So I'm not going to disengage from that and spend a lot of time doing exogenous control, which is doing the processing the stimulus that just grabbed my attention, that just did the, oh, excuse me, can you help me out here? That one guy that noticed seemed the only person that wasn't busy and wasn't in a hurry to get somewhere, because and we know this because they actively said, oh, hey, I'll take you, right? They were the only ones where they're like, oh, how do I get here? And he's like, oh yeah, no, I'll take you. I'll go with you to this particular place. So definitely had more attention, resources, and bandwidth to process the actual identity of the person that they were talking to. Any other thing that was possibly different about the guy that noticed? And this is a little bit trickier to notice, because it has to do with the guy that noticed and the person that he noticed about. Okay, so think about it. Think if you can remember in your mind characteristics of the person that almost noticed a change, and the characteristics of the person that you did notice a change on. Because this is one of the things that in the real world, if we want to take change detection out of a sort of like, well, I can show you two pictures and you can't notice the change, kind of parlor trick, into the real world, one of the things that we can see is, how can this affect things like racism, things like sexism, things like conspiracy theories, things like fake news? There are connections between change detection and a lot of these ills that are plaguing our modern society. So any idea? We'll start off with the first one. How might change detection feed into, or this phenomenon of change detection, elucidate some ideas about what might be causing racism? So how might change detection, this idea that we are not noticing the changes in our environment, how might that impact or contribute to, or be a possible explanation for some forms of racism? Yeah, so you're close. You're knocking on the door. There's definitely some things that are not being noticed, and there's definitely some stimuli that are not being processed, and then that has its effects on how racial attitudes are formed and how they're maintained. So let me give you, this was a difficult one, so I'm gonna give you a hint. So once again, think back to the person that noticed. And did they share any characteristics with the person that they did notice? And we'll talk about that when we talk about the results of this study, which was the first study that kind of showed change detection in this. It's called the DOOR study, in this door swapping technique. Yes, the guy you noticed was bald. The person you did the noticing was bald. So why would that have anything to do with it? Well, let's take a look at the DOOR study.
This video shows a participant from a 1998 study by Daniel Simons and Daniel Levin. Watch what happens as the unsuspecting pedestrian provides directions. The young man on the left is one of the experimenters. He has approached the white-haired man and asked for directions. Watch closely as two people carrying a door pass between them, and the first experimenter is replaced by someone else. Like many of the people in this study, the pedestrian was entirely unaware that he was talking to a different person. Approximately 50% of the people approached in this study didn't notice when the person they were talking to was replaced by someone else.
Approximately 50% among the first to demonstrate change blindness. Approximately 50% of the participants didn't notice the change. But not just that 50% of the participants didn't notice the change, there was a clear effect in terms of age of the participants. So some of the participants were 20 to 30 years old, other ones were 35 to 65 years old. So what percentage, if you had to guess, what percentage of 20 to 30 years old subjects noticed the change? Does anybody think it's as high as 60? Anybody want to go higher, 70? Do I hear 80, 80, 80? Can I get 85, 85, anyone 85? No? 100. 100% of the 20 to 30-year-old subjects noticed the change. 35 to 65 years old, none of them noticed the change. So when these two individuals were swapped out, people that were 20 to 30 years old noticed. They were the ones that were like, whoa, wait a second, what happened to the other guy? Like, was this a prank show or something? Am I on, candid camera or punked? I think it was pre-punked anyways. You can tell this was pre-YouTube because it took them like 2 minutes to get to the footage. But anyways, 100% of 20 to 30-year-olds noticed the change. Nobody in the 35 to 65-year-olds noticed it. So the experimenter said, you know what, let's take a look. And this is age related, right? Maybe older individuals are just worse at noticing changes, right? Maybe this is just something that we lose our ability to do. So what they said is, well, let's take a look at construction workers instead. So they took the same two experimenters, the same two people, and they dressed them up as construction workers. They didn't have any 35 to 65-year-olds in this experiment. However, the 20 to 30-year-olds, instead of performing at 100% when they were construction workers now, they only noticed it 33% of the time. So how might this affect racism, sexism? The hint here is that you are more likely to notice changes for people that are in group versus out group people. So if you have a part of your identity that puts you inside of a group, you are more likely to notice changes that are in that group versus changes that are outside of that group. So when you take a look at students and young individuals, they will notice changes in other students or young individuals, right? Because they are part of that in group. They identify, you know what, I'm a university student, I'm a 20 to 30-year-old. And when you switch out a 20 to 30-year-old, they are way more likely to notice that change, which means that they are way more actively processing the information that comes from people within their group. The older individual did not process that information because he did not see them as part of his group. He's like, well, I'm a professor, this is a student. I'm an elderly individual, this is a younger individual, not part of my group. Of course, this isn't like a cognitive aware strategy that they're saying. But basically, that person is outside of my group. I'm not going to process their information. I don't notice the changes that occur with that individual. And when it was recreated with construction workers, now these construction workers, now they're out of the group. So I'm a university student, these are not university students. And therefore, that's why the processing of that information went down, because now they're not part of that in-group, they're part of the out-group. So what does this mean for racism? What does it mean for sexism? Basically, it says that if you identify people as being out of your group, then you are less likely to notice changes between those individuals. You're less likely to notice differences between those individuals. So, you know, that kind of stereotypical response, true, but stereotypical, where people will say, well, all those people look alike, right? All those people act the same. All those people insert whatever those people are. Basically, what they're saying is that all those out-group people, not my people, not my in-group, but all those out-group people, they're all the same. Well, of course, you perceive them as all the same if you have this change blindness occurring where you're not processing that information. Because they're out-group, you're not processing the information. So of course, you can generalize way more easily across across characteristics because they are part of that out-group. You literally do not see the differences between people in an out-group as readily as you do within an in-group. And that is one of the ways that things like racism and sexism can perpetuate. Because a lot of times people in our society, they're like, well, how can people still be racist? When you have all these examples of, successful, law-abiding, wonderful examples of these individuals, how can they still hold these racist beliefs? And one of the reasons is because they do not notice the differences between those successful individuals and then anecdotal evidence or other evidence of not so successful, not so law-abiding, fits the stereotype individuals. They don't notice those differences because they're part of the out-group. So one thing that, and we'll wrap this up right now, that is also why the bald guy noticed the change. So one of the things that, people who define their identity, oftentimes define their identity with things that are extreme about them. So for example, I'm 6'4", being a tall person is one of the things that is part of my identity. And I know it's part of my identity because I feel threatened a little bit whenever I see a taller person. And I know I feel threatened because I will stand up straighter when I see a taller person walking down the hallway. I'll just kind of be like, oh, okay, who am I anymore? But basically, that bald person identified as a bald person. When you change to another bald individual, he immediately said, well, this is an in-group person. I wasn't talking to an in-group person. I was talking to an out-group person. Something weird is going on here. So this is one really, really nice example of what we do cognitive psychology for. Because change detection in a cog lab, in a nice little demonstration, doing the door, trick, that's nice. It's a magic trick. You can use it to impress your friends, on a weekend party or something. That's not that important. But when you take a look at change detection and say, what does this mean for our society? How is this propagating racism and sexism and other, ills in society? That's when it becomes powerful. Because you're not going to change detection. Change detection is in our minds. It's the way that we work. You can't train change detection out of people. So what does this suggest that we do? This basically says, well, we can't train change detection out of people. So what we need to do is we need to change who's in group and who's out group. And we need to make sure that people identify who is inside of their group along more productive social characteristics than what we're currently doing. But I've noticed the change in time. We have gone a little over time. I apologize, but that is it for today. So next class, we are going to jump into perception. We're a little bit ahead of time on attention or on the schedule. So we're going to jump into perception, but we'll just keep everything on the syllabus the way that it is. But other than that, we are done for today.